or so. Hello, we're going to go ahead and get started. I'm Kate Meese, Associate Director at the Local Government Commission. This is the 6th of 15 webinars we'll be hosting over the next 3 years through the Statewide Energy Efficiency Collaborative, which is a partnership between LGC, ICLEI, the Institute for Local Governments, and the 4 investor-owned utilities. The partnership was established in the CPUC decision for 2010 through 2012 to help cities and counties reduce greenhouse gas emissions and save energy. A little bit about the webinar logistics before we get started. Due to the large number of participants, everybody will be muted for the duration of the webinar. If you have questions at any time during the webinar, please type them in the question box on the control panel window with the name of the speaker your question is intended for and click the send button. If you're having any technical difficulties, write IT in the question box followed by the problem you are experiencing. We will be trying to answer as many questions as possible through the chat function during the presentations. We'll summarize the remaining questions for the speakers during the question and answer portion at the end of each panel. And we have Pat Stoner with us, who is a statewide local government energy efficiency best practices coordinator, who will be helping summarize and ask the questions. The presentations from this webinar are available at lgc.org/seek/webinars. We'll also be adding an audio recording of the webinar once it's available. Usually it takes about 24 hours. When the webinar concludes, you will be asked to complete a survey. Please take 5 minutes to provide us with input, which will help us to improve our future webinars. The goal of this webinar is to provide information about the Energy Technology Assistance Program, or ETAP. First, we'll have a high-level overview from Energy Solutions, which is an energy efficiency consulting firm that developed ETAP. They're administering the program as part of the California Energy Commission's State Energy Program and Energy Upgrade California initiative. After that, we'll hear from 2 groups participating in ETAP, the California Lighting Technology Center at UC Davis and the County of Sacramento. So with that, I'll introduce our 3 speakers from Energy Solutions and turn it over to them to get the webinar started. Forrest Kasier is a program manager of the Energy Technology Assistance Program. Before starting with the Energy Technology Assistance Program, Mr. Kasier served as staff lead for many of Energy Solutions' local government clients in the San Francisco and Monterey Bay areas, working closely with local government staff to develop integrated, cost-effective energy and conservation strategies. So we're happy to have Forrest with us. Also from Energy Solutions is Eric Ludovici, who's an associate with Energy Solutions. He'll be working with the program implementation team supporting the Lighting Efficiency Incentive Programs, NEO, or NUO, and ETAP. Prior to joining Energy Solutions, Eric's educational background included research on controlled environment farming in cold climates using state-of-the-art lighting and insulation. And lastly, from Energy Solutions, we have Elizabeth Joyce, who joined as a project manager in 2009 and works primarily in the statewide Utility Codes and Standards program, researching and advocating for new and updated state and federal appliance and building energy codes. She also promotes targeted wireless HVAC retrofit technologies through the ETAP rebate program. So thanks to all the folks at Energy Solutions for joining us today, and I will turn it over to them.
Hello, everyone. First of all, I just wanted to thank the Local Government Commission and the Statewide Energy Efficiency Collaborative for hosting this webinar today. Also, I wanted to thank Kelly and Dan for taking the time to share your expertise and experience with this group. And also, a big thanks to all of you for taking the time to participate in the webinar. So, as was mentioned, we're here to talk about the Energy Technology Assistance Program, which we know as ETAP, and how it can help local governments reduce their energy costs and greenhouse gas emissions. I'm going to give you a broad overview of the program, and then Eric and Elizabeth are going to follow up with more detail on the specific types of technologies that ETAP supports. So as was also mentioned, ETAP is a program of the California Energy Commission, and just to give you background on where this program is coming from, our funding is actually from the stimulus bill of 2009. So the Department of Energy issued grants to each of the states, and in California the Energy Commission was responsible for prioritizing that funding and developing solicitations to support the types of projects and programs they identified as being important and useful. So our company, Energy Solutions, developed a program specifically to address the Energy Commission's interest in advanced controls for commercial and institutional facilities. And out of a pool of 70 or so applicants, we were one of 3 that were awarded the funding. And we're the only program that focuses just on public facilities. So a lot of the programs are focused on commercial buildings and residential. The other thing is that ETAP is a part of the Energy Upgrade California umbrella. So you've probably started to see that logo, and I'm not sure if I need to tell you that we need to change slides, but the logo for the California Energy, or rather Energy Upgrade California is really becoming pretty prevalent. I've started to see it on billboards and websites all over. We are a part of that program as well, but as I said, that's more oriented towards the residential and commercial side, and ETAP is really focused on local governments, universities, college campuses, so public buildings and facilities. So our program runs through 2012, March of 2012 rather, and that tight timeline means we're really looking for projects that can be installed by the end of 2011. That gives us some time for contingencies, unexpected delays, post-installation verification, and also processing of rebate checks. So, really we're looking for a pretty tight time frame for getting these projects installed, and that's consistent with the purpose of the stimulus bill, is really just trying to stimulate some short-term activity. So this short window is really an amazing opportunity for local governments to take advantage of the rebates that ETAP provides on top of those already provided by the utilities. So because there's 2 different funding sources for ETAP and for utility programs, you can actually combine both rebates in a single project to really significantly reduce the installed costs of those projects. So it's really a unique opportunity, and it's only going to be available for a relatively short time. So we do have a website that describes our program in more detail. It's on a slide there. It's www.energy-solution.com/ETAP, and there's a lot of information there. There's resources on example RFPs and more descriptions of our measure areas. So please feel free to check that out. There's some good information there. So I wanted to tell you just a little bit about the technologies that ETAP supports. Eric and Elizabeth are going to go into more detail, but there's 3 basic measure types that ETAP supports, or technology categories. These are bilevel lighting for parking lots and parking garages, wireless lighting controls, and wireless HVAC controls. And the tight focus on these 3 measure types is consistent with the purpose of the stimulus program. We really are just highly focused on these in order to speed implementation in a short time period. So next slide, please. These technologies all have some things in common, namely they were picked because they typically allow public agencies to realize really short payback periods. They really produce a very cost-effective energy savings, and they also have the feature of being really easy to install. So in many cases, they provide a much cheaper and easier way of getting the same functionality that you would get from running a lot of wires through your building. Those kinds of projects in HVAC retrofits, more than just wires. Oftentimes you have major repairs needed to install the equipment that is required to obtain a given function. But with the wireless products, you can really go in there and install them pretty quickly and pretty easily. You can avoid asbestos abatement costs, which can be prohibitive for many agencies. The products are also very customizable. So the technologies we support, you can really fine-tune them to address the specific needs and specific concerns of a facility. The other thing is they typically work really well with building automation systems that may already be in place. So they're all BACnet, or most of them are BACnet compatible, and so you can integrate them very effectively into your existing automation environment. Next slide, please. So, to get into what ETAP actually provides to local governments, I'll focus on the first and the last of those two things. The first thing is we can do the assistance up front to help you identify projects. So we can actually do site visits where we send out members of our technical team to inspect the facilities and identify which facilities are good candidates for our measures. Because they're so targeted, they're not always good matches. So we do that upfront work to help you figure out which facilities make sense to retrofit. And we provide audit reports that will give you an analysis of what the expected energy savings are, what the energy cost savings and maintenance cost savings will be, and what the payback on that project would be expected to be. So it really gives you all the information you would need to make a decision on the project. On the back end, the rebates we provide are available after installation to offset the cost of the project. And these are significant rebates that, as I said before, you should keep in mind are in addition to any of those available through your utility partners. So we've worked closely with engineers at all three of the large electricity utilities in the state to familiarize them with our measures. So applications, that are for projects that involve our measures will not be news to them when they're submitted. So we've done that to try to streamline the process and make it as easy as possible for the projects to capture both rebates. In between the upfront auditing and the rebates, we can provide a range of different services that we would really scale to the needs of the individual agency. So in some cases, agencies may be in a position to handle the project largely on their own. In other cases, you may want help with RFP development or evaluating contractors, identifying other financial resources. So we can provide as-needed assistance to help you get the project done and to move forward. So we can talk specifically about your needs when you give us a call and we start the conversation about your projects. So next slide, please. The steps to participation, things to keep in mind. Cities, counties, special districts, community colleges, universities throughout California are all eligible, and all of our services are free of charge to participants. So all of this is funded by the stimulus money from the Energy Commission. So no-cost consultations. Then we can help identify which projects are the best fit. Contractors are always welcome to submit bids. We do try to publicize any bids that we're aware of on ETAP projects on our website and refer you to the agencies that are holding those bids. So if you're a contractor and you're on this call, you can look to our website to get ideas about where projects are moving forward. Manufacturers, we do accept new products from time to time. Our focus is really on, because of the time frame, our focus has been on implementing projects with the existing qualified products. But if you have a product that you think fits one of our measure areas, definitely contact us, and there is a process for including new products if they meet our specifications. And then really I think the biggest audience for this webinar, the public building owners, there's really just this huge benefit right now of being able to combine rebates and technical assistance from ETAP with the rebates from your utility for the next 6 months or so to really reduce project costs below what they're likely to be anytime in the near future. Next slide, please. So we have enrolled already a large number of cities, counties, and other public institutions. I think our website might say 47 now. I think it's actually a little bit higher than that. It's updated constantly. So we've identified a large number of savings. We still have a significant amount of funding left, though, for projects. So the time is now to really reach out and figure out if there's any good fits with your agencies, and we can work with you to reserve an incentive specifically for your project. That is the end of the high-level overview of the ETAP program. I'm going to turn it over at this point to Eric, and he's going to walk you through our lighting technologies.
Thanks, Forrest. Next slide, please. So my name is Eric Ludovici again, and I'm a technical lead for two of the lighting measures that ETAP supports. The first of which is bilevel lighting, or lighting in parking lots and parking garages. And for bilevel lighting in parking lots and parking garages, ETAP provides technical assistance and financial rebates for lighting retrofits in both garages and parking lots, and in addition, stairwells and pathways may be considered. Next slide, please. So the opportunity for savings in lots and garages come from the fact that the majority of existing lighting in these situations is provided by relatively inefficient HID lamps and outdated fluorescent fixtures. So by upgrading to the latest technology in lighting, you can really save a significant amount of energy and money, as well as likely improve the overall light quality in the area. Next slide, please. So in addition to those savings from changing from old, outdated technology to new, efficient lighting technology, there are additional opportunities for savings in this particular application due to the fact that intrinsically these types of areas generally have large stretches of time where there's little to no occupancy. So you can picture a garage in the middle of the night from, say, 3 to 5 a.m. or some other range of time where there's absolutely nobody in the parking facility. Yet, since safety is such a concern in these areas, going to no lighting is usually not an acceptable savings opportunity or not acceptable savings strategy, and full light output is present at all times. But with the emergence of bilevel lighting technology, there's now really an opportunity to essentially have a facility that has two different lighting scenarios while still only having a single type of fixture. So you can have a scenario where when no occupants are sensed in the area, the fixtures will operate at a lower wattage and a slightly lower light level that still meets the safety needs of the space, but is slightly lower than what would be a comfortable level when patrons are present. But then when occupants are actually sensed, the fixtures will turn to their full power output before the patron actually enters that area that the fixture lights up. Next slide, please. So as I just mentioned, the areas where bilevel lighting is applicable and ETAP supports are parking garages, parking lots, stairwells, and pathways. That's mainly because these are the places where there are usually long stretches of time with no or little to no occupancy, and generally have fixed output light wattages currently. Next slide, please. So the energy savings that can be achieved from installing this bilevel lighting technology are really twofold. So as I've discussed first, by upgrading our lighting technology from older, inefficient lights, such as HID lights, to a newer, high-efficient lighting, such as LED, high-efficiency fluorescent, or induction fixtures, in most cases you can cut the wattage considerably while still maintaining the existing light levels. The second portion of the savings come from the reduced wattage that occur when the fixture operates at low power mode when nobody is present. And this can typically add another 15 to 25% onto the energy savings. So the total potential energy savings for these types of projects is really actually quite wide. It can be anywhere from between 25 to 70% depending on the project. However, it should be noted that a project with 25% energy savings may still be just as financially attractive as a project with 70% energy savings. And to kind of illustrate an example of when that may be the case, so a case where you have relatively low energy savings, you might have an existing garage that has first-generation T8 fluorescent lamps and old, relatively inefficient ballast. in this type of situation, you have a potential to upgrade just the lamps and the ballast in the fixture with new high lumen lamps and extra efficient ballast that are bi-level capable. And in that type of case, you might have energy savings anywhere from 25 to 30%. However, since you're only replacing the lamps and the ballast, the project cost is usually quite low, which still makes the payback quite attractive. So then on the other end of the spectrum, picture a garage where you have an existing 175-watt metal halide fixture that burns 24 hours a day. So that's a very, very high wattage fixture. And that gives the opportunity to really upgrade to the latest technology, bi-level LED that's capable of dimming down to something around 30% of the high light level during no occupancy times. From that, the savings can be upwards to 75%. However, you're going with the latest technology in the lighting, which is generally the more expensive technology, but the savings are so great that your payback is still going to be quite attractive. And I should note that beyond just the greater savings that are available from LEDs, there are a lot of other benefits from upgrading to LEDs, such as better lighting distribution, so more even lighting on the ground and much longer lifetimes. Next slide, please. So some other benefits beyond just energy savings that upgrading to bi-level lighting can achieve are, first of all, improved light quality, as I talked about before. That comes in two different variables. The first being color temperature. So you can see from the image on the screen on the left, that's a garage with a high-pressure sodium lamps that has a very low color rendering index, and really can be quite unwelcoming to a lot of people and not really be perceived that well. On the right side, you have a garage that has a much cooler temperature lamp and usually is interpreted as being much more welcoming and safer. Another advantage of the improved lighting quality is the distribution of the lighting itself. That's another big advantage of LEDs, is that with LEDs you can direct the light you can direct each LED's light specifically where you want it to be targeted to be, which avoids having high and low spots between fixtures and underneath fixtures, which allows you to reduce the wattage even more. So another benefit beyond just the savings measure, or the savings from bi-level lighting, is improved personal safety. As I mentioned before, usually people perceive the yellow temperature or warmer temperature of the high-pressure sodiums to be less safe and less inviting than cooler temperatures. And then lastly, extended life or lamp life is a major benefit of upgrading to these new technology in the lighting. So for example, a 175-watt metal halide fixture typically has a lamp life of around 10,000 hours, while qualifying ETAP LEDs have a minimum lifetime of 50,000 hours. And the industry is quickly moving that upwards to 70,000 hours as a standard for the lifetime. So that's anywhere from 5 to 7 times longer than the existing lamp life. Next slide, please. So with the extended lamp life, you also really decrease your maintenance costs over time. And actually, the Department of Energy has done a lot of studies on this, and they've estimated that on average it costs somebody $225 to relamp a pole-mounted fixture, and that includes the time for the electrician to go out there, the rental of the equipment to reach the fixture, and the material or cost itself. They've also estimated that it costs around $75 to relamp a parking garage fixture. So if you can avoid 4 of these relampings over the lifetime of the product, then you stand to save quite a bit of money just from the maintenance savings alone. And then also, if you decide to implement wireless controls along with your bi-level lighting, you have remote identification of lamp failures and outages that really prevents you from having to do regular site inspections to detect these failures. Next slide, please. So for the bi-level lighting measure, ETAP has 3 different tiers of incentives that are all on a prescriptive basis, which means they're per fixture. So they aren't dependent necessarily on the existing lighting and the amount of actual energy savings that you're anticipated to save. They're dependent on the technology of lighting that you decide to implement. So for bilevel LED fixtures, ETAP offers $200 per fixture that's installed. For bilevel T8, T5, and induction fixtures, ETAP offers $100 per fixture. And then if you're only doing a lamp and ballast retrofit, like I talked about in the scenario where you're just replacing the lamps and the ballast and not replacing the actual fixture itself, ETAP offers a $40 incentive. Next slide, please. As Boris touched on briefly before, in addition to ETAP incentives, these projects also typically qualify for utility incentives, which can be layered on top of the ETAP incentives. Typically in PG&E territory, as well as SE and SDG&E, those utility rebates are at 5 cents per kWh savings, and then $100 per peak kW reduction. There are also some prescriptive rebates similar to the ETAP rebates that are offered in PG&E territory, at least, for both fluorescent fixtures and, I believe, induction fixtures. Next slide, please. So to give you a typical idea of project energy savings and financials, there's a table. This table shows a few different scenarios. I'm going to walk through the first line item. All these scenarios are based on a 175-watt fixture quantity in the garage. So the first line item shows that the existing fixture is a 150-watt high-pressure sodium fixture with estimate our existing annual energy use of just under 300,000 kilowatt hours per year. With the retrofit fixture, we have a recommended 90-watt LED that's bi-level capable, so can reduce to at least 50% of the wattage when nobody is present, which is estimated to use around 120,000 kWh per year. So right there alone, you have over a 50% reduction in energy use. And associated with that reduction in energy use, you can save an estimated $25,000 per year at an assumed rate of 15 cents per kWh that you're paying. With the ETAP rebate at $200 per fixture, that will lower your project cost even more by $35,000. And then adding on the utility incentive at 5 cents per kWh and $100 per peak kW, you reduce the project even further by another $10,000. So by the end of the project, you're looking at a net project cost of under $100,000 for a project that's just under 200 fixtures, which is an average to mid-size parking garage. And that comes with a payback that's under 5 years. So this concludes the discussion on the bilevel lighting. I'm sure there's some questions out there, and please feel free to keep those coming in. For the time being, we're going to move on to the next our wireless lighting measure, and then we'll address those questions at the end of the discussion on the actual measures themselves. So the second lighting measure that is available under the ETAP program is for wireless lighting controls in both interior spaces and in parking garages. So if you use wireless lighting controls as part of your bilevel parking garage project, ETAP will actually rebate whichever measure comes back with a higher value. Next slide, please. The savings opportunities from wireless lighting controls come from the fact that typically interior office spaces usually have little functionality and controllability of their lights beyond basic on-off capabilities, and sometimes control by time clocks. So at the beginning and the end of the day, the lights will come on and come off at a set time. This really leads to the opportunity to reduce light levels on a fixture-by-fixture basis according to occupant preference, daylight potential, smart scheduling, etc. Typically, if you wanted this type of control, it would require running low-voltage wiring between all of the fixtures and having that being ran back to a central controller, which is quite expensive, time-consuming, and intrusive, so it would interrupt your normal business, and really comes back with project costs that make the savings not attractive enough, and the project becomes cost prohibitive. Next slide, please. So as I mentioned before, our ETAP supports wireless lighting controls in parking garages, lots, and also in interior spaces such as office spaces, libraries, etc. Next slide, please. So on the screen, there's an illustration that shows really the basic components of how a wireless lighting control system works. Basically, each fixture is equipped with its own lighting controller, which sits in the ballast cavity itself, and is about the same size as a ballast, about the same size as a stick of butter, actually. And then, so each of these controllers is present in a fixture, and these controllers then communicate with all the fixtures surrounding it, which creates a mesh network that operates on Zigbee protocol, if anybody's familiar with wireless networks at all. And so in this situation, you have all these fixtures that are actually communicating together. So if for some reason one fixture goes offline, it doesn't interrupt the network, and the signal just jumps around it. So additionally, you see components under the personal controls, daylight controls, occupancy sensing. All of these controls also are equipped with a wireless sensor. So you can have a wall control that isn't necessarily wired to any fixtures at all. All it has is a wireless sensor in it. Same thing with an occupancy sensor or a photocell. And now these controls become part of that network. So once you have this network set up with all of these fixtures communicating with each other, all of these controls communicating with each other, this information is then channeled through a gateway, which then feeds into the building network and is accessible through an interface that's either online or on your desktop computer or even your iPhone. And that allows you to see real-time performance of the system on a fixture-by-fixture level, letting you know what fixtures are on, what fixtures are off. And from there, you can reprogram and re-optimize your system continuously, controlling which fixtures respond to which inputs. So you can have X number of fixtures that respond to Y occupancy sensor, and you can have one fixture that is specifically programmed for the needs of one person. And all of these different programs can layer on top of each other with different priority levels, allowing you to really have the most optimized control and optimized savings that you can get from the system. Next slide, please. So as I was mentioning on the previous slide, the savings opportunities from wireless lighting controls really come from a few different places. They can all be layered on top of each other to maximize your savings. So the first is through occupancy sensing, the second being through automatic scheduling, the third being through daylight harvesting, the fourth being through personal control. So each person can control their own fixture if they would like, or not, if depending on whether you want to give them that control, simply by going online. And then lastly, all of these saving strategies can be layered on top of each other, like I said, with different levels of priority. So really, we estimate that the cost savings from these types of projects can be anywhere from 10 to 50%, which is also really dependent on the individual space itself. Next slide, please. So some of the other benefits, like bilevel lighting, that come along with wireless lighting controls are increased personal safety, and also longer lamp life and lower maintenance costs over time. So like touched on briefly in the bilevel section, one of the advantages of having a wireless lighting system is that you can see the system's performance in real time from a desktop computer. So you can see if you have fixtures that are out, you can see what fixtures are at what light level. You can reprogram them from this interface, all without having to actually go to the physical location and check the lamps on a regular basis. So by doing that, you can save quite a substantial amount in maintenance savings. Next slide, please. So now the ETAP rebates that are available for the wireless lighting controls measure are different from the rebates that are available for the bilevel measure in the fact that they're calculated rebates, so they aren't on a prescriptive basis. They're calculated based on the estimated energy savings that you'll achieve from the system. And that estimated energy savings would be a result of an actual audit that ETAP would do and present to the agency before a decision is made. That way they know what their incentive is going to be, and they know what their estimated they know what their estimated costs will be before actually making a final decision on the project. But the ETAP rebate that's available for these wireless lighting controls is 18 cents per kilowatt hour saved annually. And like the bilevel measure, additional utility rebates are applicable, typically at 5 cents per kWh and $100 per peak kW reduction. Next slide, please. So to walk through a basic project spreadsheet or project analysis for wireless lighting controls, just going to go through the top line item, and these are all based on facility sizes. So for a facility size, a relatively small building, 25,000 square feet, you're estimated to save almost $16,000 per year in energy costs, coupled with an $18,000 ETAP incentive, then adding on a $9,000 utility incentive. The overall project cost is anticipated to be around $63,000 and a payback of less than 5 years. So like the bilevel lighting measure, these are relatively low-cost projects that are unintrusive, take relatively short amount of time to install, and are very cost-effective and offer quick payback periods. And that concludes the discussion on the wireless lighting controls. So I'm going to pass it on to Elizabeth Joyce, who's going to talk about the wireless HVAC controls that are supported by ETAP.
Thanks, Eric. So yeah, my name is Elizabeth Joyce, and I'm on the tech team for the wireless HVAC technologies that ETAP is supporting. As Forrest mentioned, there are 2 specific technologies that ETAP supports that I'll go into. Next slide, please. So just some of the general kind of benefits of both of these wireless HVAC technologies is that they allow improved control of your fans or your equipment without a lot of the difficulty of rewiring or redoing ducting. Obviously, there can be significant energy savings. There is also, your facility managers can get improved performance data from the zone sensors and use that to help them with maintenance and retrocommissioning. There's improved zone level control over your equipment operation and over zone temperatures. Both of these technologies are, like the lighting technologies, low cost, particularly they're low cost alternatives to equivalent, more complicated retrofits. And for these 2 specific technologies, they're kind of equivalent to a VAV, variable air volume retrofit, or a DDC, direct digital control retrofit. Finally, again, like the lighting, wireless lighting technology, they're minimally invasive with easier installation compared to the equivalent retrofits. So this is good for issues, again, such as asbestos, or if you don't want to disturb your building occupants or can't have a long install time. Next slide, please. So the first technology that ETAP supports is the discharge air regulation technique, or DART, which is made by Vigilant. And the idea behind DART is that it's a fan speed control technology that uses zone temperature sensors of discharge air temperature to maintain occupant comfort and maintain zone temperature while reducing fan speed and reducing airflow during times of low load, saving energy. And a DART system is made up of the zone discharge air temperature sensors, which are arranged similar to the wireless lighting control in a wireless mesh network that feeds in through a central hub or gateway. And this is coupled with variable frequency drives on your central air handler fans that are then controlled according to the data that you're getting from your zones. And this is equivalent, or can get you equivalent savings to a VAV, variable air volume retrofit, at a fraction of the cost. So again, at about what we've seen, 10% of the cost of a traditional retrofit, minimally intrusive with significant HVAC energy savings. Next slide, please. So how does DART work? As I mentioned, it's a fan speed control technology that allows turn down of your central air handler fans to deliver appropriate airflows to meet the zone air temperatures. But at the same time, by running your fans at lower airflow, you're saving a significant amount of energy. Just cutting the airflow in half can save 81% of fan energy based on the way fans work. Furthermore, delivering less air requires less heating and cooling of the supplied air, so you can get heating and cooling savings as well. One thing to note is that a DART project will require installation of VFDs on your supply and return fans if they aren't already installed. Next slide, please. So what makes a building a good opportunity for DART? So any buildings with a constant air volume system, constant air volume air handling units are a good opportunity. They have to be, as mentioned before, capable of being retrofitted with VFDs or already have VFDs. Your HVAC system needs to be in good condition. You need to be able to operate the outside air dampers. One mention is that there shouldn't be any zones that are underserved, typically are rogue zones that kind of drive the building loads. In this case, you can still install DART, but that particular zone will always be calling for cooling and heating, and so the energy savings might be reduced. Finally, there shouldn't be any baseboard heating or packaged units. In those cases, it won't apply. And you can find more information on the website. Actually, Vigilant recently changed their name from Fetterspiel Controls, but the website there should still deliver you to the correct site. Next slide, please. So the second technology, the second wireless HVAC technology that ETAP supports is the wireless pneumatic thermostat, which is made by Cypress and Viro Systems. And the idea behind a wireless pneumatic thermostat is that it is a direct replacement for an existing pneumatic thermostat, but it provides wireless control and allows a DDC-like functionality. So similar to DART, it's a fraction of the cost of a traditional DDC retrofit, which is going to require a lot of wiring, etc. And it can also give you significant HVAC energy savings depending on the way that it's used. Like DART, it's a non-invasive, simple retrofit. Existing thermostats are removed and wireless pneumatic thermostats are put in their place. They're integrated directly into the existing pneumatic system. Next slide, please. So what are some of the savings opportunities that can be obtained with wireless pneumatic thermostats? So first, remote set point enforcement, temperature set point enforcement, and remote monitoring of zone temperature and branch pressure in your pneumatic system. Optionally, you can get a deadband capable thermostat, which allows a temperature band in which there's no heating or cooling, for example, 68 degrees Fahrenheit to 72 degrees Fahrenheit. WPTs allow for programmable setbacks for night and weekend operation, so you can set the temperature back at night when no one's there. In these cases, you can lock it out from occupant override, or you can allow occupant override, say if somebody's working late at the office. And in this case, then your facility staff could get a cell phone notification, for example, of that occupant override and know how the system's operating. If a central energy management system or building management system is being used to control the central equipment in the building, then WPTs can integrate with that energy management system and can do strategies like resetting the supply air temperature or resetting the duct static pressure to allow additional energy savings in times of low or high load. Finally, if you're enrolled in a demand response program, WPTs can be used to automatically respond to demand response events and bring down your peak load during those times. Another benefit, which I'm going to talk about in a little bit, is that there are non-energy savings benefits that we've seen to be pretty significant as well, like maintenance savings and the ability of facility staff to get more data to do troubleshooting and retro-commissioning. Basically, facility staff don't need to go around the building adjusting and checking every thermostat to get the data they need. Next slide, please. So where should you look for if you're looking at WPTs? A building needs to have a pneumatic system, and it should be in working order, no concerns about leaks, etc. WPTs are compatible with a wide range of existing pneumatic systems, Johnson, Honeywell, Siemens, Robert Shaw, etc., as you see on the screen there. WPTs can work with or without an existing building management system. If there isn't a building management system, then the data is again passed to a central hub or gateway and accessed over your local area network. If there is a building management system, WPTs are BACnet capable, and so you can integrate the operation of the WPTs with the rest of your building. And there's just the website there if you're interested in learning more information from Cypress and Viro Systems about the product. Next slide, please. So kind of as I mentioned before, there are some maintenance and operation considerations and benefits from both of these technologies. First, both of these devices are battery operated. The system will monitor and report battery power levels, and when a battery runs out, you'll know and be able to replace it. Depending on the use, the batteries might last a year, multiple years. It really depends on how they're being used. For WPTs, for example, they guarantee at least 2 years, if not more, of battery life based on operation. Next slide, please. As I mentioned before, there can be significant maintenance savings from both of these technologies. Basically, your facility staff are able to get additional diagnostic information from the devices, be able to monitor zone temperature in the case of the WPTs, the branch pressure for your pneumatic system, to identify problems before occupants notice, figure out how the zones are operating and fix them. This kind of eliminates the need for periodic retro-commissioning and allows for real-time retro-commissioning, so to speak. Next slide, please. So the ETAP rebates that are offered for the wireless HVAC technologies are like the wireless lighting rebate, 18 cents per kWh annual savings. And similar to wireless lighting, these are calculated based on the estimated project energy savings. ETAP will come and collect facility data from personnel through audits and use that data to calculate savings based on the predicted system operation. Next slide, please. Again, there are also corresponding utility rebates for both of these technologies through utility customized incentive programs. For example, I think these are the PG&E rates on screen, 9 cents a kWh, $100 per peak kW, and $1 per therm. Other utilities offer similar rebates, and depending on what program you're in, you might have higher rebate rates available to you. Next slide, please. So finally, here are just some example projects for both DART and WPTs. And just the things to kind of zero in on, the annual kWh savings and therm savings are calculated as I previously described based on facility data. The cost of the project is going to depend on the characteristics of the system. For DART, it'll depend in part on the number of zones controlled and on the number of fans that are being controlled. For WPTs, it's going to depend on the number of thermostats. You can also see on the right the ETAP rebates and the utility incentives based on the criteria that I discussed before. One thing that I should notice is that the ETAP rebate is typically cost capped at 100% of project costs, but it'll pay up to that amount. Next slide. I think that's it for the wireless HVAC technologies. And I don't know if now is a good time to open it up to questions. Kate?
Yeah, thanks, Elizabeth, and to our other speakers from Energy Solutions. We don't have any questions that have come in yet. A lot of good information that you all presented, and I think folks are maybe just taking a little time to digest it. If anybody does have any questions, please go ahead and right now type those in on the question box, and we'll go ahead and reply to those as we continue on with our webinar. So with that, we'll move on to the California Lighting Technology Center, who is working with the ETAP program. Kelly Cunningham is the Outreach Director at the California Lighting Technology Center. Her responsibilities include providing information about the California Lighting Technology Center and energy efficiency lighting technologies to the lighting industry, project partners, and the public through online and printed publications, tours, events, and reporting. So with that, I'll go ahead and turn it over to Kelly.
for the nice introduction. Next slide. So California Lighting Technology Center, for those of you who are not familiar with us, we are a nonprofit at UC Davis, funded by, next slide, the Public Interest Energy Research fund within the California Energy Commission. We are also supported by NEMA, and we're founded in part by the U.S. Department of Energy with the small startup funds. Next slide. Can the presenters also hear that feedback? No. Okay. So our mission is to stimulate, facilitate, and accelerate the development and application and commercialization of energy-efficient lighting and daylighting technologies. And we do this in partnership with utilities, manufacturers, end users, builders, designers, researchers, etc. So we have to have this team of all important partners in order to accomplish these goals. Next slide. So I'm going to give a few examples to support the work that ETAP is doing and to give our perspective on interior lighting controls and some applications you may not have thought of for some bi-level or multi-level lighting, and then give a few examples of installations of bi-level exterior to wrap up. Next slide. So lighting control strategies becomes quite complex when you start to consider all the different layers that you can add together to reach what we feel is the ultimate solution, all the way down to the granular time of use savings. So these are just a basic outline of the different types of control that you would have through implementing various types of lighting control strategies. Next slide.
Kelly, we're getting a lot of feedback. Are you on your computer? Are you using the computer mic to present?
Pardon?
Are you using the mic through your computer to present?
No, I am not.
You're on the telephone?
Yes. Shall I continue?
Yeah, go ahead and continue. It's stop for now, and we'll try and just keep plugging away.
Yeah, I'm not sure what else to do. So if you add all these together, what you have is dynamic, demand-sensitive lighting for interior applications. This is the combination of all of those strategies in the previous slide put together to achieve ultimate control. Next slide. So let's look at stairwells. For CLTC, we consider this an early win. We also consider it a proven strategy. Stairwells are often overlooked as places lighting is on 24/7, regardless of occupancy. And through our work over the last 5 to 7 years, we now are aware of at least 5 manufacturing companies that make excellent products that have integrated sensing that you can use in stairwells, and then also you can combine basic stairwell lighting with controls, not necessarily using an integrated unit, to achieve the same results. Next slide. So it was introduced in the initial presentation on lighting, what this can save. We typically see a 40 to 50% savings in stairwells, and we do have full reports offered to all the attendees of this webinar and to the public, should you need those after this, to show and demonstrate that savings. In addition, it does provide reduced maintenance, and there's multiple technologies you can use to achieve this. LED or fluorescent would be the obvious choice, and many manufacturers within that offer very reliable products. Next slide. So this is an occupancy graph that shows generally the 50% savings in stairwells that we've measured. This one in particular is from UCLA, and you can see where we were pre-retrofit and where we were post-retrofit, and really who's using that stairwell at what time of day. This can also add an additional security benefit by showing who is where in the building, and if this information wasn't available before, you can start to really see how your building is used. Next slide. Now let's talk a little bit about corridors. Most corridors and most commercial, hospitality, and educational buildings are illuminated continuously regardless of occupancy rate. So we're really looking at these as an excellent next step to move into spaces where we can reduce our energy use without compromising the quality of the light for the occupant, and then not really make an intrusion or change in the way that people see or use those spaces. Next slide. The busiest corridors in commercial applications, from what we found, are vacant about half the time. That's pretty significant. We're not doing our work in the hallways. We're in our offices, classrooms, meeting rooms, conference rooms, other areas. So our proposed best practice is at least bi-level control, lights to 50% less on vacancy, automatic to 100 on occupancy, but you can also trim and set those lights at 80% maybe when it's occupied with ample illumination for your occupants in those spaces. And this is a good strategy for both retrofit and new design. Next slide. For example, we did an audit here at the UC Davis campus, and UC Davis uses about 73 million kilowatt hours per year for electric lighting, and we found that approximately 20% of that pie goes to corridors, leading the campus architecture and design management team to really take a hard look at what control strategies could we put into place to reduce this. Next slide. We also did some little incremental studies to say, okay, we know that it's big use, we know that we can reduce, so where do we go from here? And we found that those corridors that we measured were really only occupied 18% of the time. Next. And this study was done in Boehner Hall at UC Davis, and we'll be releasing a full case study on this within 2 weeks of this webinar. Next. We really didn't have to ask anyone to vacate the premise to take photographs, and this is pretty indicative of the spaces that we found throughout the campus and that people typically find throughout their own buildings. Next. So corridors, again, is an excellent place to start looking at your facilities and saying, could this be a place to create savings? And we're not talking about creating a cave, someplace where your occupants feel uncomfortable. Rather, we're looking at even increasing their security and safety by providing light when they need it, and when no one's there, why do we have them on? Next. So one of the strategies that we used in this corridor study was the Adura wireless integrated photosensor and motion sensor. We tested this in 2 points in our facility, one in a hallway that we consider a new construction example, and in a second hallway which is a retrofit example. Next. Collecting feedback from this system and measuring, and we can monitor on a daily basis, we found that, of course, the bathroom hallway is a little bit more occupied at 16%, but what we formerly considered a high traffic area was actually occupied only approximately 6% of the day, achieving a 65.4% energy savings. Of course, you'll notice at the top it says high mode is 70%, low mode is 30%. So we did extend beyond that 150 best practice to consider 70-30 as providing ample illumination for the space and 30% when no one's around. Next. And here is the occupancy pattern of that particular high traffic area. And of course there's more traffic during the day, and as we would expect, nothing going on at night. Next. So Again, this is a great example of a small micro study that we truly believe is exportable to public facilities throughout the state and could really help us achieve some of our longer term energy goals. Next. And the system can be expanded beyond hallways that are not exposed to daylight. In the center of the image there, we have just an example of a daylighting sensor. If your areas, stairwells, hallways, etc. also include daylighting options, then absolutely this should be incorporated into the strategy. Next. And we do think it is appropriate for both LED and fluorescent. It's a technology neutral solution in that regard, as long as that technology is outfitted with the proper electronic belts, etc., to be able to handle the dimming capabilities. But this isn't about one product. It's about a variety of products working together to achieve maximum savings. Next. For small offices, we've done several studies over the past few years that show excellent results for automatic on when the occupant enters the space, and then if they need more light, they have somewhere to go, so they go up to 100 at that time. Automatic off after the space is vacant for up to 30 minutes, and we found that that even is not necessary. 15 would be fine, and a tremendous amount of savings can be achieved through these measures. Next. So a few slides on exterior lighting. Next. And some of this was covered earlier in the presentation, so I'll go quickly through this. Many adaptive exterior lighting products do offer 30 to 80% depending on what was previously installed. And it is achieved by coupling the lighting controls with efficacious dimmable sources. Next. So those lighting systems reduce to 50% or less during low traffic or vacant evening hours, and should be equipped with sensors and possibly time scheduling controls. And you get that 30 to 40% savings from those controls. And of course, we saw those estimates for relamping both inside and out, so the maintenance savings are evident. It is an important part of the process when you're planning a bi-level exterior project to have your security forces, especially if you're a campus or public institution, on board with this decision. And here at UC Davis and on the other campus we've worked at, our police forces have been pleased with the results and have been on board with assisting us in implementing first tests and then system-wide retrofits. Next. Here at UC Davis, at the top deck of our south entry garage, we installed LED luminaires, which did indeed achieve for this particular space an 80% savings. Next. So in this case, we have sensors on the unit, and these are not networked. And this was an early test that's been in place for over a year and a half now. And we had before 175 watt metal halide, after in high mode 115 watt, but that drops down to 35 watts in low mode, and that's how we achieved that very high savings number of 80%. Next. In terms of a beyond LED, we also here at UC Davis and in other campuses throughout the UC, CSU, and community college system have looked at induction lighting as a technology that is absolutely a good fit with bi-level exterior. Next. For example, at the California Department of Public Health, we installed smart bi-level induction fixtures. And induction, you know, it has a 100,000-hour lamp life, which is often overlooked when you're evaluating the different technologies that is out there. It's important to kind of get a cross-technology comparison. And we also here had 175 watt metal halide in place before. The new luminaires are 110 watts in high mode, 60 in low mode. The savings for this site was 67%, and it does have a pretty high occupancy rate. throughout the day and evening. So even with that, we have a savings of 67%. Next. So that is the extent of the presentation that I have today. There are case studies, reports, and best practice guides available on the CLTC website that you can use to complement the valuable information that the ETAP presenters have given you at the start of this webinar. And I would encourage you to reach out to them or to me and acquire some of those materials if you are interested in looking at those studies more in depth, the methodology, the results, and if you have any questions on how to apply this to your own facility or campus. Thank you.
Thank you, Kelly. Great presentation, and thanks for hanging in there despite some of the audio challenges in the beginning. We do have a few questions that have come in that I'll go ahead and read out right now. One question was whether on-bill financing can be used in conjunction with these rebates for the ETAP projects, and the answer is yes, they absolutely can be used. According to Forrest Energy Solutions, Edison is oversubscribed, but they understand that there is still funding available in PG&E and SDG&E territories. We had another question asking whether incentives apply to parking lot lighting wireless systems. And currently, the answer is currently parking lot lighting would only be eligible for the Bilevel incentive per fixture. And I see right now that Michelle Pruitt with Edison has typed in that Edison does have a wait list available for on-bill financing projects. So if you're interested in using that financing, then go ahead and make sure you get on their wait list. If anyone else has additional questions, please go ahead and type those in using the question box on your panel. And I'll go ahead and turn it over now to Dan Mendoza, who is a professional mechanical engineer and a LEED accredited professional and has been the County of Sacramento's energy manager for the past 4 years. Previously, he was a consulting engineer designing green and mission-critical facilities throughout the United States. So with that, I will go ahead and turn it over to Dan. Dan, are you there? You're unmuted. You're ready to go. It looks like Dan may have stepped away for a couple minutes. While we wait to get Dan on the line, does anybody have additional questions? It looks like Tom has a question. Is there an approved list of Bilevel parking lot fixtures available? And I'll go ahead and unmute Energy Solutions to see if they have an answer for that.
This is Eric with the ETAP program, the tech lead for Bilevel Lighting. So the question was whether we have a qualified product list for Bilevel lighting fixtures that are pre-approved for ETAP incentives. For induction fixtures, we absolutely do have a list of what manufacturers we know meet our minimum requirements in terms of efficiency and fixture performance and lifetime performance. For LED fixtures, we do keep an ongoing list of fixtures that we know qualify and meet our specification. Generally, we try to base our qualification on the Design Light Consortium's qualified product list for LED fixtures, with the additional requirement that it meets Bilevel or it's Bilevel capable. So you can go to designlights.org and download a version of their qualified product list that that includes all of the fixtures that would be eligible for ETAP incentives. And that list is actually a pretty good rule of thumb for the LED fixtures that will qualify for additional utility incentives as well.
Great, thank you. Dan, do we, oh, let's see. Dan, are you with us?
Yes, did that work?
Yes, great.
Okay, great. Can we go to the next slide? Okay, the presentation, I'm just going to go over the background of the county's energy program, as well as the summary of our projects, specifics on the wireless HVAC projects, and some of the implementation considerations. Next slide. All right, the county's energy program was created in 1992 to save energy and money, and currently we manage 52 county-owned facilities, or about 3 million square feet, and we assist with about 2 million square feet of leased facilities. We pay about $9 million a year in utility bills, of which about $6 million of that is electricity, and about $1 million or so is natural gas, with the rest water and sewer. In addition, we provide consulting services for other county operations. Currently, we're managing about 14 projects with a total value of $5 million. The projects that we look at are selected based on the need of the facilities, the payback, the financial payback, and whether the maintenance will be the same or lower, and the funding source goals. We have about 70 projects that are in our queue, and so we've kind of narrowed that down to the 14 I mentioned. The projects we're talking about today are being funded originally out of the EECBG ERA funds, and out of that we created a revolving fund. So we're using that as well as the assistance through the ETAP program to fund these projects. Next slide, please. Energy Solutions came out to our site after we narrowed down the projects. We had about 9 to start with, where we thought would be viable based on the initial criteria they gave us. And then of that, we ended up with the 3 projects that we'll be actually implementing. One is a Bilevel project in one of our garages, and the other 2 are the wireless HVAC control projects, where we're looking at the 2 different wireless HVAC technologies that were discussed earlier. Next slide, please. All right, the first one we chose was one of our parking garages at our primary health facility. And it's a 2-story, 100,000 square foot, or roughly 50,000 square foot per level parking structure. Next slide, please. And that had a total of 95 fixtures. We had 67 fixtures on the first level, and then we had 28 pole-mounted fixtures up on the top deck. We decided, based on the economics, that we would go with the high-performance T8 bilevel fixtures on the first floor, and then with the LEDs up on the top deck. We are going back, because of the better rebates that are available, now looking at LEDs also on the first floor. Some of the drivers for us on this were obviously the energy savings, in addition to the reduced maintenance cost. As mentioned, well, LEDs we know have a lower maintenance, or I should say a longer life cycle, and so that really can reduce our maintenance costs. So even though when we do our projects we can't count that in the payback, it is something that is a direct benefit to our operations. So here's the, on the right you see the table there, and this is kind of a summary of the project with the power reduction, a little over 10 kW, energy savings, about 74,000 kW per year, cost savings, about $6,700 per year, with a net cost of about $33,000 with a payback of 4.9 years. This translates to us to a cost savings of about 7 cents a square foot for the parking structure, and then a project cost of about 33 cents a square foot. On this project and all the other projects, where we're at right now is we're just putting together the specs and the drawings. So as to what we'll realize on these, it's going to be till the end of the year before we finish up. We're getting assistance not only from Energy Solutions, but the City of Sacramento is a little ahead of us on this process, so we've been consulting and working with them. They've been very helpful in this effort. Next slide, please. Specific to the HVAC projects, we have one where we're doing the DART system and one where we're doing the wireless pneumatic thermostats. These two buildings, once we kind of funnel down the ones that seem to be viable, the things we're driving this is we have these old pneumatic systems, and it's just made it very difficult for our operations staff to know what's going on in the way of trouble calls and whatnot. So this was one of the drivers, was not only the energy savings component, but also to give our operations staff better information. The other, of course, was the reasonable payback. In our case, we were shooting for less than 5 years on all of our revolving fund projects. Some cases we've been a little bit higher, but that's kind of like our benchmark, is about 5 years or less. In addition, we wanted to pick some buildings that were of a reasonable size that we wouldn't overcommit, but we wouldn't undercommit in the way of, if we did a project too large and we decided the technology didn't work, then we felt that that would be too risky. And if the project was too small, then just the general administrative cost of the project would kill it from a payback standpoint. Next slide, please. All right, so the first building we chose was actually the building I occupy, and we're in Sacramento. And this is a two-story building. If you look at the photograph on the right, essentially that upper part is a two-story structure, and then the lower part is a one-story structure. And there's 2 units feeding that top area, which is the two-story. It's basically the left side is fed by one constant volume unit, and the right side is fed by another. And then that lower area, it's a one-story building, is fed by a separate third unit. These are all constant volume, dual duct units, and the one on the bottom is a multi-zone. So they basically have a hot deck and a cold deck, and these are pneumatic systems for the control at the zone level. We also have 2 air-cooled chillers that provide the cool water, the chilled water, as well as 1 central boiler. And this is all basically office space. Next slide, please. So this is kind of a rehash of what Elizabeth Joyce mentioned earlier. But Vigilant is the one that's making the DART system, and they have the wireless thermostats, in our case, that will be put adjacent to all of our existing pneumatic thermostats. And sorry, these are wireless thermometers. And then they can monitor and adjust the system remotely. Next slide, please. All right, so for this building, we don't have VFDs in the facility. So part of the project cost is to go to the 3 units I mentioned earlier and add a VFD to the supply fan as well as to the return fans. In total, we have 51 zones. So if we look at the energy savings, about 75,000 kilowatt hours per year, with the cost savings of about $12,000 per year, and net project cost of about $38,000. So we look at our, once we get the rebates, the payback is a little over 3 years, which is really, really good for us. Estimated cost, and so if you can kind of keep this in mind as we look at the next facility, is about $1.24 square foot, with the estimated savings is about 39 cents, 40 cents a square foot. Keep in mind, though, this includes the cost of putting in VFDs. And just a couple other quick numbers. Energy savings against the whole building is about 14% total. 14 to 15% on the energy savings for us. Next slide, please. The benefits that we're hoping to realize with this particular project is reduced energy costs, the ability for our operations staff to be able to remotely monitor this facility for troubleshooting, help us a little bit with some commissioning, and then a big thing they've been asking for, maintenance staff's been asking for a while, is VFDs, because the static pressure runs pretty high certain times of the year on the system. And so we're getting those VFDs with this project. Some concerns we have is whether the energy savings will really be what's projected. If temperature control is going to work as well as is also expected, because we have these wireless sensors that we will put some settings on, and they may not align with what happens with the pneumatic stats, meaning somebody can go to pneumatic stat and change it, and then the wireless sensor would still be thinking it's supposed to be monitoring at different temperatures. So just going to be interesting to see how that works out. The next item is whether it'll integrate well with our campus BMS. We currently use Siemens Insight out on this campus, and that the DART system is supposed to be BACnet compatible. What we've been discovering is it has limited BACnet capability. So we're gonna, and we're still, I know it's kind of dynamic and changing, so we'll be interested to see how this all really plays out at the end, how well it'll integrate with what we already have. And that's similar to how well the VFD control will work. And then, of course, what is the battery life on these sensors? Next slide, please. So that's that building. As mentioned, we're just basically at the point of plans and specs and going out to purchasing in the next few weeks to get this out on the street. For the other building, this is our Sheriff's Administration building. This is located about 10 miles from me. It's a 4-story building. It was built back in the 60s. It's about 15,000 square feet per floor. Most of it's office space. It operates pretty much 8 to 5 with a few areas that are 24/7. A while back, they had upgraded that. There's a big air conditioning unit or air handling unit that sits up on the roof, and it serves the whole building. They put VFDs on that, and then they went ahead and put, they upgraded the dual duct constant volume zones to dual duct variable air volume zones, but are still being controlled by pneumatic thermostats. So in this case, we didn't have to pay for the VFDs, but we were still having control being done at the zone level by the pneumatic thermostats. And so we wanted to get that information at the zone level up to the building management system and then to our county-wide system. And so that's where we see the strength of these WPTs made by Cypress as being a really good fit for this facility. This one also has, this facility it has a central boiler, and then chill water is coming from another building. There's a central plant, and there's a set of chillers over there, including one very high efficient chiller. Next slide, please. So as mentioned, this would be the Cypress wireless pneumatic thermostats. A lot of great things, a lot of promise associated with this piece of equipment. We've actually had a chance to get one early on and install it and play with it a little bit. It was just doing local control. Seems to work okay. There are some concerns about calibration. It's a very sensitive piece of equipment, but there are a lot of lockout features associated with it also. And it wasn't that hard to get a sample, so if you're looking at doing one of these projects, definitely talk with your local suppliers and see if you can get at least a single thermostat or possibly get a trial system where you can communicate with it through your local network. Next slide, please. So this project had X zones. That was really 100 zones. We have 2 existing VFDs. Estimated cost for this project is 90 cents a square foot, and estimated savings about 14 cents a square foot. Energy savings about 59,000 kilowatt hours. With gas at about 2,000 therms per year. Cost savings at $8,400, which translates to about 5% of the energy associated with that facility, and that's including from the central plant energy that we get next door. The payback is about 6.5 years. So if we look at this number and we go back, and I'll just go back and read what it was from the previous facility, because we're doing a comparison, is we say the estimated cost is about 90 cents a square foot. For the other facility, it's about $1.24 a square foot, but in that case, we had to buy VFDs. So that was a little bit more expensive. But the energy savings of this one is about 14 cents a square foot, whereas that one was 39 cents a square foot. So don't expect the same energy savings, but we do see this as potentially being a good fit within our operations. Next slide, please. And the benefits, energy cost, reduced energy cost, remote set point adjustments. This is really, as Elizabeth mentioned earlier, there's some great things about this night setback. We can do changes if we decide to change our temperature settings throughout the year. Currently, if we say that summer setting is 76 or 78 degrees and the winter setting is 68 or 70 degrees, and maybe have a fall and a spring setting, it can take half a day or so for somebody to walk around and change those settings on the pneumatic stats. With this, we can do it for one spot, takes a minute, or maybe it's just part of a program sequence, it just happens automatically. So there's definitely some time savings there, as well as some remote information that's allowable through the network. In case a trouble call comes in, somebody doesn't walk over there with a temperature probe. They can actually read it. They can read it from a remote location. Some of the concerns we have, again, will the energy cost reductions be as projected? How well will this integrate with our campus VMS? In the case of that location, whereas we have Siemens Insight, where I'm at this location, it's Johnson Metasys. The particular building that this is located at is an older version of Metasys, and it's not BACnet compatible. This equipment communicates through BACnet, so we're having to deal with that challenge of bringing this newer technology into an older VMS system. So there'll be some challenges we're going to get through there, but so far we've come up with some solutions. Will the product be durable enough? Amazingly, the sheriffs are pretty abusive to our equipment. So that's one of the challenges. They've already been, the test product we got out there, they were making a lot of changes to it initially, and so we found out that Cypress offers one of these where you can actually not have adjustments on the panel. They actually cover up those buttons that raise and lower the temperature. So that's an option we're looking at. And will the battery life be as much as they mentioned at, like 2 to 4 years? Next slide, please. So how we're delivering these projects, these are generally smaller projects, less than $100,000, and we have a certain amount of overhead if we do projects. We give them out to our in-house project management team. We have to pay them. They're $150 an hour or so. In addition, if we go out on the street to contractors to install them, there's just so much money and time associated with putting together a contract, going to purchasing. So on these smaller projects, I'll actually be doing the project management. My costs are covered through my program. And then we're looking at doing direct procurement of the materials through our purchasing department. We'll put together a spec, and then they'll contact the various suppliers that make these products. In the case of like the Dart product or the Cypress product, it's going to be fairly limited, but that's the approach we're looking at. And then we'll have our in-house electricians and maintenance staff do it. For larger projects, and we had actually established this last year, we have a process that's called JOC, which is Job Ordered Contracting, which allows us to pre-select contractors through fixed prices on like a job book. You can imagine like a means catalog where there's a labor rate and a material cost for a particular item, like 10 feet of pipe. It says so many hours of labor and so much cost for materials with multipliers for your local region and type of hours. We pre-bid that, in our case, out on the street, and we get contractors to bid multipliers. And then we award to the lowest multiplier, and then we set the contracts at anywhere from $500,000 to $3 million. And then as we have projects come up, we issue what's called a job order. It can be a couple $1,000s to a couple $1 million. But what's great about that is once the contractor's already been selected, the process to issue the job order takes about a month. So we go through the 3 to 4 month process of getting the contractor on board, which we did last year, and now we have available to these projects, but we can get them on board now in a month. And then once we get them on board, they do all the purchasing, they do all the installation, so it just really accelerates the process for our larger projects. So if we end up with any of these projects after these initial 3 we're doing, where they exceed $100,000, we definitely will be looking at using our JOC to do that. But as I mentioned here on the slide, that most of these projects are going to be less than $100,000. Next slide, please. And that's all I have. Questions for me, or are we going to hold them?
Thanks, Dan. We will go ahead and take questions. I don't see any that have come in for you just yet, but I will give Energy Solutions an opportunity to talk about one of the questions that came up. And if anybody has any questions for Dan or any of our other panelists, please go ahead and take the opportunity to type those in now. This is your chance for questions. So Energy Solutions, I'm going to go ahead and unmute you so you can answer the question that came in, which was, are Wi-Fi non-Zigbee control systems eligible under the program. Forrest, are you there?
Oh, yes, thank you, Kate. So we don't have any specific prohibitions against Wi-Fi, but we don't have any products that are currently qualified that use that approach to wireless control. So basically the way that it works for us, we have specifications for our wireless lighting controls measure, and we have specifications for our wireless HVAC control measure. And so if a product, if you have a manufacturer or if you're a local government and you have a product that you're interested in and you want to see if it's eligible, then you can submit it to us and we'll evaluate it according to our specifications, and then it's possible for it to get approved that way. And if you are interested in a copy of the specifications for either measure or even the bi-level measure, you feel free to send me an email or give me a call, and we can send that to you. So we don't have, to answer the question, we don't have any particular prohibition against Wi-Fi, but there aren't any qualified products right now that are based on that approach.
Forrest, can you talk a little bit about the qualification process and, just a range of timing for how long it takes for a product to get qualified?
Yeah, that's a great question, and I want to contextualize it by saying that our focus really in ETAP, because it's a short-term stimulus-funded program, has really been on implementation of projects using the technologies that are already qualified. So that's really our mandate from the Energy Commission is to take these products that we had submitted as part of our proposal originally to the Energy Commission and provide the support and the rebates needed to catalyze projects for getting implemented. That said, we have accepted a couple of additional projects since the program started, and the way the process works is, as I mentioned, we have a list of specifications. Typically, a manufacturer will contact me, and I will direct them to our technical services manager, and the two of them hash out how exactly the product meets the specifications. And usually there's not really a form. It's really more of a case-by-case basis where the manufacturer would respond to each of the requirements in our specifications and describe how their product does meet them. And upon approval by ETAP Technical Services, we would then submit that to the Energy Commission for final approval. If all the documents are in place, and the approval could happen in a fairly short period, but we can't really commit to a particular time frame for turning that around. It really varies from product to product, and sometimes there are particular issues related to specific products that need to be worked out. So, if you're interested, the bottom line is, if you're interested, contact us, and we can start the process and take a look.
Great, thanks. We had a couple more questions come in. The next one says, ETAP is for projects that are installed by what date?
Yes. So we're looking for projects that are installed by the end of the year 2011. But that said, if it's going to trickle over into the early part of January, we still want to talk. The drop dead date is really February 13th. That's when we feel like that's the last date we would be able to accept projects and really give us time to do the verification and processing that is needed to issue the payment.
Okay, and then another question following up on the question about funding available for bi-level parking. Is there a list of bi-level parking lot light fixtures available on the ETAP website?
Currently, there's not a list, and like I was saying before, generally for LEDs, our qualified product list is based off from the Design Light Consortium's qualified products list. But like the wireless lighting measure, our qualification process is based on an internal specification that we have for minimum fixture performance, and that can be provided to to somebody that's interested also by contacting Forrest directly, and we can provide that on a case-by-case basis. But to answer the question shortly, a qualified product list is not available on the ETAP website.
And the reason for that is, there's a large number of potential products out there, and we don't want to bias anyone for or against any particular product. There might be products that would qualify that we're not aware of, and so we want to kind of have an open-ended approach to that product category.
Great, thank you. And I see that Kelly mentioned that they have a catalog of bi-level parking and area lighting and case studies. Kelly, do you want to expand on that a little bit?
Yes, on our website under resources, catalogs and specification sheets, we have a peer solutions for parking lots and garages catalog, and what this is through our work with the Energy Commission, through our peer demonstrations program, we've collected what we are aware of as different manufacturers that do offer products that fit a bi-level classification. And we've also included the case studies that we've done that test these out in real-world scenarios in one 21.3 megabytes, so fairly substantial download PDF for review. And to echo what was just said, we are not promoting one manufacturer over another, but rather trying to collect and offer to those interested in implementing a bi-level parking solution a range of products that we have looked at and know have this capability. So in addition, if there are manufacturers who offer products to include in the catalog, they're welcome to contact us to have them added. But I hope that those on this call will find that catalog helpful.
Thanks, Kelly. And I did just post the link to that catalog for all of our participants to see. Any other questions that folks have? Any other final remarks from our panelists?
Sure. I'll just mention, if you're a local government agency and you're interested in participating, if I didn't mention this before, the way to start is just to send me an email or give me a call, look at our website. We can start the conversation that way. And the way we're organized is we have a team of staff that are assigned to be the individual point of contact for each agency. So we can quickly identify whether there's some potential projects and get you assigned a person to help walk through your facilities and figure out whether there are any good fits. So I think that we just posted my email address there. That's great. And definitely feel free to get in touch with me, and we can discuss the opportunities that may exist at your facilities.
Dan, any closing remarks?
No, just want to get this done and see how well it works.
Kelly, closing remarks?
I also am aware that at least one of our listeners has wanted to find out where the bi-level stairwell case studies that I spoke about were, and those are also on our website, and Kate has just provided a link to download those. And like I mentioned, the corridors one is brand new and will be released shortly, and I will respond to that caller directly. And thank you all for listening, and I hope that more of you will take advantage of this great program, and feel free to contact CLTC about the things that we have presented about, me in particular. And thanks for providing this opportunity.
Kate?
Yes.
I would like to make one more comment,
Sure.
and that is that the folks at Energy Solutions have been extremely helpful in helping us figure this out, and I would recommend to any of the local governments out there, even if you just have an inkling of something, please talk to the folks at Energy Solutions, because they do so much legwork to get this worked out for us that it really made my job a lot easier to move forward.
Great, thanks. And I see that there is another question that came in. Is there an application for applying for these rebates?
Yes, absolutely. There is an application, and it's really something that we would prepare. It's pretty simple, and once we talk through your project and we have a good sense of what incentive it would qualify for, and then we would prepare that for you, and then you would need a signature from someone at city or county or local government staff, and then come back to us, and that's what would reserve your incentive. So it's really a process of talking over the specific projects to get a sense of where the best fits are and what the best incentives are before we actually draw up that application.
So then is the first step to contact you, Forrest?
Exactly. The first step is contacting me, and I will hook you up with one of our staff to coordinate a closer look at your facilities.
Great, and I did post Forrest's email up there, so feel free to flood him with emails after the webinar to follow up on the ETAP. So thanks everybody for participating. Thanks to our panelists. We really appreciate you all sharing all the great information. And please remember that in closing out of the webinar, you will be asked to fill out a survey. That really helps us to keep these webinars useful to you all as local governments. So please take a few minutes to provide us with some input. It's really useful for us. Again, this webinar is eligible for AICP credit, so go to their website to take advantage of that as well. And that concludes our webinar. Thanks so much for joining us.
Thank you.